This is section 3.3, and this is on complex numbers. These are imaginary numbers, and so that's a different number system than the real system which we have been steeped in. So the two big things we need to remember from the get-go is this is the value of the imaginary unit I. It is equal to the square root of -1. And then if you square anything, you get what's under the radical. So I squared is -1. We need to remember that complex numbers can be written in standard form, and the standard form is a plus bi. A is the real portion, and bi is the imaginary portion. So every number in the world can be written that way. So if we think about 5, just the number 5, that could also be written as 5 plus 0i. -5 minus 2i, that's already in that form, and the real part is -5, and the imaginary part's -2i. If you had -3i, that could be 0 minus 3i. So we need to think about every number could be written that way. If you have the square root of a negative number, we don't leave the negative in there, and it can be written as I times the square root of a. So remember that. We're going to see those. Conjugates. Every complex number has a conjugate, and all that happens is you change the sign on b. So the conjugate of 4 plus 6i would be 4 minus 6i. The conjugate of -5 minus 2i would be -5 plus 2i. All right. Now, operations on complex numbers. When you're adding or subtracting them, you deal with the like parts. So in other words, in this problem here, we have the real parts I've highlighted in yellow and the imaginary parts in blue. So 3 plus a -5 is a -2. 2i minus 6i is -4i. Now, on the multiplying or dividing, we could do that by hand. We are not going to do that by hand in the course. We're going to use our calculator. And when you use your calculator, you're going to find I at second and the decimal key. So let me pull the calculator up, and we'll clear what's there. So if I wanted to do this problem, and this one here is different than this one here. So let's just do this one so that we see. If I put negative, well, I want to put parentheses. So parentheses, -2 minus 3. Now I need the I. And right here above the decimal, so second and the decimal key gives me that. I hit parentheses, open another set, 1 plus 4, second decimal, close, and hit enter. And I do get, let me pull that over, 10 minus 11i. And there is a process that we could go through with using FOIL and then combining like terms and all that, but we're going to do it with our calculator, which is really quite nice. All right, the only other thing that we'll look at in this section is possibly solving a quadratic equation that ends up with imaginary solutions. So here's a quadratic. Our a is 1, b is 3, c is 5. Quadratic formula. Plug in and you have -b, so -3 plus or minus square root of 3 squared minus 4 times 1 times 5 all over 2 times 1. And I think the parentheses inside here are really important to keep you on track. So -3 plus or minus 9 minus 20 over 2. Well, 9 minus 20 is -11, so we've got this. And there's no way to clean that up except pull the I out and leave a positive under the radical. So that would be your final answer. So I think that's good for the lecture notes. Let's go look at our problem set. All right, number 1, square root of -49. What we need to note is that 49, without the negative, is a perfect square. So the square root of a negative perfect square is 7 and then I. So that's your answer. When we don't have a perfect square, we're going to have square root of negative 3. We know that we're going to pull the I out. That takes care of the negative, and we have I square roots of 3. Square root of negative 54. That has a perfect square in it, the factor of 9. Let's look at that over here. So if you pull it out, you could say that's the square root of negative 9 times the square root of 6. This, like the square root of negative 49, is 3i square roots of 6. So that's your final answer. Square root of negative 20. That can be broken down to the square root of negative 4 times the square root of 5. That's 2i square roots of 5. Number 5, simplify by using the imaginary unit. So think of this as what you might come up with if you were solving a quadratic equation. We've gotten this far. Well, let's take this square root of negative 16. That's equal to 4i. So now I've got 4 plus or minus 4i over 4. Always look to see if all three of these numbers can be divided by something. Well, in this case, they can all be divided by the 4. So we end up with 1 plus or minus I over 1. So we don't have to write that over 1. And we have these two as our solutions. Same thing with number 6. Let's do the negative 72 under the radical. We can break that down to the square root of negative 36 times the square root of 2. That part is 6i square roots of 2. We'll put that back in. We'll substitute that back in. And now we look at these three numbers. We have to say, is there anything I can divide all of them by? If you only have 2, you don't get to do the division. You've got to have all three divisible by something. Well, they're all divisible by 3. So we have negative 4 plus or minus 2i square roots of 2. That becomes a 1. So our two answers are here. All right, now we've got some operations. If you have the square root of a negative 11 times itself, the square removes the square root when you're squaring it, when you're multiplying it by itself, and you get what's inside, which is a negative 11. On this, let's multiply inside, and we get square root of 441. Negative times negative is positive. And that's a perfect square, so that is 21. All right, now we're back to adding. We're going to add the real parts and add the imaginary parts. 3 plus 8 is 11. 6i minus I is 5i. 1 minus 2 minus 5i. Let's distribute this minus, so you have 1 minus 2 plus 5i. So 1 minus 2 is negative 1 plus 5i. On these, again, we're going to do it with the calculator, and you will just put them in just like it is. 4 plus 3i times 5 minus I, use second decimal, you get 23 plus 11i. So you can do that same thing here. Now, with the division, the parentheses is not here, but when you put it in, we need to do that. Let's look at that one on the calculator. Let me clear. So we want 5 divided by parentheses 1 minus I. And close. And we get decimals. So they are expecting that you're doing them by hand. And so we'll just hit math, and the first option's fraction, hit enter, and enter again, and you get 5 halves plus 5 halves I. The other way that you could do that instead of the parentheses is do an alpha y equals and hit enter, and on the top put the 5, hit the right arrow, and down here put the 1 minus the I. And then we can just hit enter, and we get that in fraction form already. So either way, if you want to use the parentheses, that's great. And if not, you can do alpha y equals and get the fraction. All right, so I did that here, and it's 27 over 17 plus 11 over 17i. Here's one with decimals. Just be careful as you're putting those in. Evaluate with a calculator, as if we weren't doing it already. It says round to the nearest thousandth, so you will get it in decimal, and just make sure you have 3 places when you round it. I to the 42nd. Let's talk about how we do that. Since 42 is an even number, write it as 2 times 21. So I to the 42nd equals I to the 2 times 21. That's I squared to the 21st. Well, I squared, remember the very first thing we looked at in the notes, I squared was -1. So -1 to the 21st, that's an odd number, so it'll still be a -1. If it were a positive number that we ended up here, then it would be a +1. So keep that in mind for those. Number 18 is one of those quadratic formulas, and it just is exactly like our examples, and we got -4 plus or minus 2i for our answers. All right, I think that's our problem set. That one should really go pretty quickly, a lot of it on the calculator.